Hello students, today we are going to solve the problems given in the exercise number 1.1 in our number system. Okay, so first question is given here that is 0 is a rational number. First question. So tell me, so 0 is a rational number or not? Yes, it is a rational number. Can you write it in the form of P upon Q, where P and Q are integers and Q is not equal to 0? So two conditions should be there. We have to express it in the form of P upon Q, and where P and Q are integers and Q should not be equal to 0. First of all, it is yes, big yes, obviously yes. So 0 is a rational number because we can write 0 as like 0 upon 1, 0 upon 3, 0 upon 100, or anything. We can put any integer value here except 0. Okay, so we can express that way. You can put any integer value other than 1, 3, or 100, no problem. So that is the answer of the first question. So you remember 0 is a rational number since all the integers are rational numbers. Now I have to erase the first question. Next I am going to second question. So here it is. In our second question, the question is written as find 6 rational numbers between 3 and 4. So we have to find 6 rational numbers in between 3 and 4. 3 is an integer, 4 is an integer. So in between 3 and 4, 3 and 4, those are integer as well as rational numbers also. We know that the number of rational numbers are infinite in between given to any rational numbers or integers. Okay, so what is the method to find out the rational numbers between two integers? So here we have two methods. The first method is very simple. We are discussing about, suppose we have two numbers R and S. So we know that R plus S divided by 2 is okay. R plus S by 2 always lies between R and S. So if R and S are two integers, then the middle value will be R plus S divided by 2. We can find out the number. So if we follow that rule for in our examples here, we can say the number between 3 and 4 is, we have to find out the number one by one. Okay, so first the rule is that we have to add them, 3 plus 4 and then divided by 2. That means 7 by 2. So that is our first value, which is lies between 3 and 4. Again, the second number, that means the number between, now we have to find out in between 3 and 7 by 2. Okay, 3 and 7 by 2. 7 by 2, just we get the value in between 3 and 4. So the rule is same. We have to add them, 3 plus 7 by 2 divided by 2. We will get the another value. So here you see we have 2 as a LCM. So here it is 3 times 2 means 6, plus here it is 7. So 2, that means 13 by 4. That is our second term. Okay, so next third, the number between, suppose we are going to find out the number between 7 by 2 and 4. So 7 by 2 plus 4 divided by 2. So here it is again, 2 is the LCM. Okay, it is 7 plus 2 for the 8. 2 4 times 8, that means we can write here, actually we have to divide, that value is divided by 2 means what, actually multiplied by 1 by 2. So 2 it becomes 4, 2 times 2, and here it is 15. So that is our third value. In this way we can find out lots of numbers. Now we can find out in between 15 by 4 and 7 by 2, anything. You can take any number. So let us take, suppose okay, in between 7 by 2 and 13 by 4. Okay, so same thing, 7 by 2 plus 13 by 4 divided by 2. That means in our upper part here it is LCM is 4. Here it is 2 times 7 means 14 plus 15. It is 2. Now it becomes 8, and at the upper part it becomes 29, isn't it? 14 plus 15 is 29. Okay, that is our fourth value. Now we have to find out another two numbers. So that is the number between, suppose we are going to find out 3 and suppose 13 by, it is not written earlier, 13 by 4. So 3 plus 13 by 4 divided by 2, how much? Upper part it becomes 4. 3 4 times, that means 12, isn't it? 12 plus 13, here it is 2, so it becomes 8. Here it is 13, sorry, it becomes 12. It becomes 12. So 12 plus 13 means how much? 25. So 25 times divided by 8. So that is our fifth number, and the final number should be equal to, suppose we are going to find out in between 15 by 4, that value, and 4, the last value, and 4. So how much? So again 15 times 4 plus 4 divided by 2. Okay, now it is feasible. Okay, the upper part LCM is 4. Here it is 15 plus 4 times, that means 16. So at the denominator it becomes 8, and numerator it becomes 15 plus 16 means 31. So those are the numbers. Those are the numbers in lies between 3 and 4. So if we write here in this way, the numbers are, the first one is 3. Okay, so next one is, just for demarcation, that is 7 by 2. Next one is 13 by 4, 15 by 4. Here it is 29 by 8, 25 by 8, 31 by 8. So it becomes, the final value is equal to 4. So that is, we have 6 rational numbers. Okay, if you take another values, you will get other rational numbers. Since the number of rational numbers in between two integers or two rational numbers is infinite, you can find out lots of numbers. Okay, so that is our first method. Now we will discuss about the second method. That method is most important and most simple one. Okay, let us discuss. I have to erase this one. Now suppose second method, we are talking about second method. In our second method, what should we have to do? Here we can write 3 and 4 as rational numbers with denominators as 6 plus 1 equal to 7. So the first value 3 can be written in the form of rational number. That means 3 equal to actually 3 upon 1, 3 by 1. So if we multiply both numerator and denominator by 6, it becomes 18 by 6. That is the first number. We have to find out the next number. That means 4. 4 can be represented as like 4 divided by 1. So again 4 1 multiplied by 6, that's sorry, not 6, here is a I have wrongly put here. Actually it should be 7. So I have to erase those 6. Okay, those values. Now again I'm going to put here. That means 7 times 7 by 7. Since it is the 7, isn't it? Just remember it. If you do something wrong or error happens, it is better to remember. Okay, so anyway, take it easy. Here it is 20, again wrong, 21 by 7. Actually the first value becomes 21 by 7 and the second will become 4 times 7 divided by 1 times 7. That means 28 times divided by 7. So that is the second value. We have to find out the rational numbers in between 21 by 7 and 28 by 7. So obviously it is easy to find out the rational numbers at a time. So how we can write those rational numbers? So 21 by 7, that is our first rational number. That is given rational number. Okay, so we have to we find out 22 by 7. The next one we have to add 1. Okay, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7, and finally the given rational number is 28 by 7. Actually 28 7 means what? Actually 4. And 21 by 7 means what? Actually 3. Since we have to find out the 6 rational numbers, that is why we just add 1 to that 6 and it becomes 7. We have to multiply the denominator with 7. That is the rule to find out the rational numbers in between two rational numbers. Okay, so that is another method. Now you see the question should be arise, why those values are different as we have got in earlier case. The difference is, since as I already told you that the numbers of rational numbers in between two any integer or any rational number is infinite. Since it is infinite, you can find out lots of rational numbers. Okay, so all of them are unique, definitely unique, then different. That is also correct. The answer is correct. Okay, so next we should move to our next question. So again, find 5 rational numbers between 3 upon 5 and 4 upon 5. So here it is, you see answer this time we have to find out 5 rational numbers, and given 2 rational number already, 3 upon 5 and 4 upon 5. So we can write here we can write 3 upon 5 and 4 upon 5 as rational 4 upon 5 as rational numbers with denominator equal to how much? Since it is 5 plus 1, that means 6. We have to multiply both the rational numbers with 6 by 6. Okay, the first value is 3 upon 5. It can be written as 3 upon 5 times 6. Here it is 6. That means 18, and here it is 30. Okay, that is our first value. And the second value or number is equal to 4 upon 5. That means 4 times 6, 5 times 6. That means 24 times 30. Okay, so we have to find out now 5 rational numbers in between 18 by 30 and 24 by 30. Again, we can write here the rational numbers are, here we use the second method only. Okay, you can try the first method of your own. So the first value, given value is 18 by 30. That means actually that means 3 upon 5. And what is the next value? What will be the next value? Is 19 by 30, and here it is 20 by 30. Here it is 21 by 30. Here it is 22 by 30, and here it is 23 by 30. And finally we can write the final value, that means 24 by 30. Actually 24 by 30 means what? 4 by 5. We can write them as reduced form also, no problem. So first one is, we can write here 3 upon 5. So second one can be written as how much? Since 19 is a prime number, it cannot be divided, so it remains same. So but here it is, we can cut 0 and 0. Okay, it becomes 2 by 2 upon 3, and here it is by 3, it becomes 7 by 10. Okay, it becomes 11 by 15, and you check it whether it is correct or not. 23 again prime number, so it remains same, and it is final value, the original value is, sorry, we give the same color so that you can differentiate it. Okay, 4 upon 5. Those are the numbers, those are the 5 rational numbers. Again, we can find out infinite number of rational numbers in between 3 by 5 and 4 upon 5. If we give here, suppose we want to find out the 100 rational numbers in between them, we have to add 100 plus 1. Okay, we can add anything, we will get that number of rational numbers. So again, next we are going to the final question answers. Okay, that is the last question, we have to give the answer. So it is a very simple question, and in a objective manner, state whether the following statements are true or false, give reasons for your answer. The first one is we have to mention whether it is true or false and give a reason for that behind the answer. So one is what is the value of one? Every natural number is a whole number. Every natural number is a whole number. Yes, it is true. Why it is true? Because whole number is a collection of natural number plus one. So we can say whole number is a collection of natural number and zero, not one, zero, sorry, zero. Along with the natural number, if we add zero, we get the whole number. So obviously natural number, every natural number is a whole number. No problem. Number two, every integer is a whole number. No, that is false. Why it is false? Why it is false? Every integer is a whole number, because -4 or -3 are not a whole number. Sorry, numbers. So those are not whole numbers. That is why every integer should not be a whole number. Number three, again, every rational number is a whole number. Every rational number is a whole number. False. Why it is false? Because in case of rational number, we can write here anything 3 upon 5 or anything, that those are the rational number in a fraction or decimal value. Because whole number, it is not a whole number. Man is not a whole number. So you can give any region, any value in that region. Okay, you can put any value of your own also, no problem. So those are the answer given we have done in our exercise 1.1. So if you have any confusion or any doubt regarding the exercise, you can put your thought or your question in the comment box. Okay.